So right at the extreme end of lunar astrobiology is the question as to whether the moon can help us in searching for not just life in the universe, but intelligent life in the universe. Because it's been recognized for a long time that radio SETI from the far side would be one way of using the moon to search for intelligent life in the universe. But there are other technosignatures which might be possible. And at the extreme end of this spectrum, we can ask the question as to whether if intelligent life has been common in the universe, whether there might be evidence left behind on the surface of the moon in the form of technosignatures, which would be non-terrestrial artifacts. Now, just because I know this sounds very strange, and just because I want to assure you that there are plenty of people who've thought about this over the years, these shows snippets from a white paper by Jacob Mistra and others that they submitted to the Decadal Survey, searching for technosignatures, proposing searches for technosignatures, and you can see that section 2 here was searching for non-terrestrial artifacts, and 2.1 was surface artifacts. And since this is the Lunar Science Symposium and we're interested in the moon, the question is, should we be keeping our eyes and minds open to searching for artifacts on the moon? So I know at this point that there's a tendency to think that this is slightly science fiction-y, this whole question, but it isn't really. So asking the question as to whether there is intelligent life elsewhere in the universe or not is not a science fiction question. It's one of the deepest and most important scientific questions of our time, because right up there with the nature of dark matter and dark energy, because there is something going on in the universe that we don't fully understand. We now know that planets are common, so we expect that life will be common. Yet we know that once life starts, natural selection starts driving life towards complexity. And at least in one place, that increasing complexity has resulted in a technical civilization. So if you expect that life to be common in the universe because the planets are common and all the rest of it, the logic points towards technological civilizations arguably being common, unless there's some substantial bottleneck between the origin of life and the emergence of technological civilizations. So we really need to try and find out whether there is such a bottleneck or not, because if there isn't, technical civilization should be common in the universe, in which case arguably we should have found evidence of them by now. And we haven't, and this is called the Fermi Paradox. So the question here for the lunar science community is whether the lunar geological record can help constrain the Fermi Paradox. The picture on the left, as you see it, is a spiral galaxy, Messier 51, and if this were our galaxy, our solar system would be somewhere here. Now, the galaxy is 10 billion years old. So it could, in principle, have had a lot of life in its history, and some of this life might have evolved to technological civilizations, and there might have been a lot of technical civilizations in the history of the galaxy doing stuff that we might expect to find evidence for. So here you recognize Frank Drake with his eponymous equation, and we've been gradually moving from left to right, filling in terms of this equation, in that we now know the star formation rate. We now know that all stars have planets, the first order, and that probably each planetary system has at least one habitable planet, more or less. We've still no idea what fraction of such planets life evolves on, or evolves intelligence, or what the lifetime is. But let me just draw your attention to something that I think is often overlooked about the Drake equation. What Drake has done by taking the star formation rate and multiplying it by all these fractions, all of that is the rate at which technological civilizations evolve, measured in civilizations per year. And then the steady state number at any given time, which is what Drake was interested in, you multiply that by the lifetime, and we have no idea. So that's what we'd like to constrain. The point is, though, if you are minded to think that the universe is full of stars, which it is, and full of planets, and probably life is common, and you're minded, as Frank Drake was, that evolution will push life towards intelligence and technology and all the rest of it. So call such view a SETI optimistic view, which has all of these factors about equal to 1. Then what that means is that if the lifetime were low, it'd still only be a small number in the galaxy at any given time. But over the history of the galaxy, there'd be an enormous number. If you were to take all of these fractions to be of the order of 1, then you're predicting one technological civilization to form in the galaxy per year. The galaxy is 10 to the 10 years old, so you're predicting over the history of the galaxy 10 to the 10 civilizations. 1 star in 10 would host a civilization if you, like Frank Drake and Carl Sagan, thought all of these. So the question is, I mean, if that were the case, should we see evidence for it? Obviously, if some of these fractions are really small, then we won't. So the question is, can we help? Is there anything that we as the lunar science community can try and do to try and constrain some of this? Well, we could search the moon for alien artifacts that have come here. You recognize the big picture here is the obelisk from 2001: A Space Odyssey. So there have been proposals, and Robert Wagner is in the audience somewhere, who wrote a paper with Paul Davies 10 years ago. We could search LROC images for alien artifacts, and we should, because we've got the data. So why would we not look? Of course, searching LROC images for alien artifacts wouldn't have found the magnetic anomaly in 2001 because it was buried. And it was a serendipitous discovery from a geophysics survey. So you never know what you should keep our eyes and minds open as we explore the moon, even with geophysical instruments. The inset here, Arthur C. Clarke's short story, The Sentinel, was published in 1951. It's a precursor to 2001: A Space Odyssey. And in that story, the astronauts did find an artifact on the surface. If you haven't read the story, I recommend it. It's an excellent example of the kind of serendipitous discovery that might be made from a pressurized rover as it trundles around, Mare Crisium in the case of this story, and an artifact was found. However, I'm not suggesting this is at all likely because we're asking a lot of the aliens. We're asking the aliens to come here, buried something, and so that is a really extreme range of what, you know. Anyway, here is Robert's paper. Sorry, how long? Oh, 2 minutes. Right. Okay. So let's just get you time to what I really want to talk about. So if you're interested in searching the surface for alien artifacts, then I'll draw your attention to the Davies and Wagner paper. In the 1990s, Andrei Arkhipov published an idea which I think deserves more attention. And he published it in rather obscure places, mostly in Russian journals. And when he published in English, it was in strange places. But the core, so it's not well known. It's not as well known as I think it should be. Arkhipov's idea was that if a civilization gets to like our stage, or where we might like to be in 50 years' time, and we start colonizing the solar system and mining asteroids, we will generate a lot of space debris. Well, the insides of rocket exhaust engines will be eroded by the exhaust, and small micron, submicron-sized particles will be put out into the interplanetary medium of the host planetary system. And ditto, all this large-scale construction activity will produce debris. The small-scale debris of micron, submicron size won't stay in the host planetary system. It will get swept out by the radiation pressure from the host star into the interstellar medium. The more technological civilizations that have existed in the history of the galaxy, the more polluted the interstellar medium will be with small scale, micron to submicron to micron scale artifacts. This was Arkhipov's idea. How much there'll be in the interstellar medium depends on how many civilizations have been polluting the galaxy with debris over the history of the galaxy. But that could have been a large number. If you're intuitively thinking that maybe the galaxy today contains a few hundred civilizations, it means over the history of the galaxy will have contained billions, because that's the logic of the Drake equation. Even if each one only lasted 100 years or 1,000 years, and if none of them developed a true interstellar spacefaring capability, nevertheless, the interstellar medium will be polluted by space debris blown out from stars into these dark clouds where it will accumulate. Meanwhile, the solar system trundles around the galaxy, well, relative to the spiral pattern, maybe 400 million years. So the solar system has been around the whole galaxy about 10 times. And the airless surfaces in the solar system may have been accreting stuff, well, will have been accreting stuff from the interstellar medium. And if in the interstellar medium there's artificial debris, then we should be keeping an eye open for it. And so put it no more strongly than that. That was Arkhipov's suggestion, and I think he's right. We should be keeping. Obviously, if there'd been no civilizations in the history of the galaxy, we won't find any debris. But if Clark and if Drake and Sagan and SETI optimists were on the right lines, that there have been billions of civilizations in the history of the galaxy, and if they, a lot of debris might have been generated. So yes, okay. So only 2 more slides. So this will obviously these are going to be needles in a haystack in the regolith. It's not something that it would require a very. Some part of it would be serendipitous, right? It would potentially serendipitous discovery. It would be more of the moon we explore. We never know what we might find, but we could be a bit more proactive than that. If in the future we're going to start using the regolith as a feedstock for a lot of ISRU and construction and other purposes, one could imagine somewhere on the conveyor belt that takes you from the bulldozer that digs up the regolith to the end processing plant, if you could install pass it through some sort of detector, like a bomb detector on the trolley that takes the suitcases from in the airport. If you could pass the regolith through some sort of detector sensitive, looking for unusual things before you destroy it in the concrete or whatever you're going to make. If you do it, if you sift through enough of the regolith, it may become possible to place some sort of limit on the number of Archimedes particles entering the solar system from the galaxy, which in turn would put some sort of limit on the prevalence of technological civilizations that have existed in the history of the galaxy, even if none of them have come here deliberately. This was Archimedes' idea. Sorry, this is my final slide. I mean, one would not build a moon base to look for alien artifacts. And we've got a long list of reasons for wanting to build a moon base, but it is the kind of infrastructure that once it's established will enable you to explore, engage in a whole range of activities on the moon, of course. But while we're doing that, perhaps we should be keeping our minds and eyes open to searching for extraterrestrial artifacts while we're at it. So,
thank you.